So far, we defined blockchain as a shared log. Then we saw how Web2 database writes become transactions. Now here's the real builder mental model. Blockchain isn't blocks and coins. It's a distributed system pattern, a replicated state machine. And once you get this, everything clicks. In the next minute, you'll understand what state means, what a state transition is, and why every node must compute the same result. This is where you stop hearing blockchain and start thinking like a builder. Think of a simple program. It has state, variables in memory, and transitions, functions that update that state. Bank example. State equals balances. Transition equals transfer from to amount. In Web2, one server runs this. In blockchain, we do something wild. We run the same state machine on thousands of computers, and they all maintain the same state. That's replication. So what is the state on a blockchain? It's the current snapshot of truth, balances, contract storage permissions. Any on-chain data, you can think of it like one giant object in memory. What updates it? Transactions. Transaction equals input, execution equals computation, new state equals output. Here's the rule that makes everything work. Execution must be deterministic. If 10,000 nodes run the same transaction, they must compute the same result, same inputs to same outputs. That's why smart contracts can't call random, fetch live APIs, depend on system time. Because if nodes disagree, the network breaks. Smart contracts are like pure functions, under strict rules. How do they stay aligned? Two things: same transaction order, that's consensus. Replay from history. Execute all transactions from the start and arrive at the same state. The transaction log isn't just history, it's the inputs that reproduce the entire system. Now everything connects. Blocks equals batches of transactions, chain equals ordered history, hashing equals tamper evidence, consensus equals agreement on order. So upgrade your definition. Blockchain is a shared computer where many machines replicate the same state by executing the same ordered transactions. That's the real concept. Remember this: state equals snapshot of truth, transaction equals request to change it, replication equals everyone executes deterministically. If you get this, you're not a beginner anymore. Next, my hash functions. That's where immutability becomes obvious.